Dear trainees, I'd like to welcome you to this e-learning unit on biological waste treatment. The main focus will be on waste treatment via composting of organic waste, so-called biodegradable waste. First, let me show you why the special handling of organic waste is of such importance. Many countries worldwide, especially developing and emerging countries, have a different municipal solid waste composition than in Europe. The main difference is a significantly higher content of organic waste and water. If I include paper, which is definitely also a type of organic waste, the organic share is very often over 2/3 of total waste. Yes, we should definitely take a closer look at how to deal with this amount of waste. Mixed municipal solid waste without any separate collection and treatment ends up on our landfills or dump sites. This causes emissions from fire, gas, and leachate. The main cause of all those emissions is organic waste. Did you know that up to 20% of the waste input to landfills is leachate, meaning liquid percolating through the landfill? And 1 ton of waste generates 150 to 200 cubic meters of landfill gas, which contains a high share of methane. Remember that methane is 21 times more dangerous than carbon dioxide. What can we do with this waste? But then, ask yourself, who will want to eat the cow? No. We definitely need another way of dealing with organic waste. Organic waste is handled separately to achieve 2 main goals. First, we significantly reduce the quantities going to the landfill and their emissions, and second, we can turn biodegradable organic waste into valuable compost and energy. And there is quite a big amount of such waste. The quantity of municipal solid waste produced in urban households is typically between 200 and 350 kilograms per inhabitant and year. In rural areas, it typically ranges from 80 to 150 kilograms. We distinguish between 2 types of organic waste: biodegradable organic waste from the kitchen and garden, and paper including cardboard. Sources of such organic waste can be mixed waste from household and commerce and pure organic waste from parks, markets, or the food industry. The percentage of biodegradable waste inside household waste can range from 30 to 80%, and the percentage of paper from 5 to 15%. These types can be collected separately or mixed. If collected separately, there are 2 main streams: organic waste and paper. Separately collected organic waste can be treated in a composting plant or a biogas plant. In a composting plant, organic waste is treated aerobically, means with oxygen. The typical treatment duration is between 8 and 12 weeks. Outputs of the process are compost, which is a soil conditioner, carbon dioxide, and water. In a biogas plant, organic waste is treated anaerobically, means without oxygen. The typical treatment duration is between 1 and 3 weeks. Outputs of the process are methane and carbon dioxide. Methane can be used for energy production. The remaining solid is treated like in a composting plant to produce compost. This will take about 6 to 8 weeks. Separately collected paper typically ends up in a recycling plant. It can be used to produce either recycled paper or energy. If organic waste is collected mixed, such waste can be treated in a so-called mechanical biological treatment plant, MBT. The separation and treatment of biodegradable waste is done on site. These plants are not designed to produce compost because high-quality compost cannot be obtained from such mixed waste. We call this CLO, compost-like output. Through the mixing, you have a lot of contaminants like heavy metals, glass and plastic parts, which are not good to have it in compost. Anyhow, the biological treatment in the MBT, which is a composting-like process, can stabilize the material. That means that its potential for leachate and gas production, as well as its quantity, are drastically reduced. After such treatment and the resulting stabilization, this material is safe for landfilling. Another option of the MBT is to dry the organic waste, also using the composting-like process, in order to produce secondary fuel, so-called refuse-derived fuel, which can be used as a substitute for conventional fuel, e.g. in cement plants. Here, the heat produced by the microorganisms in the process is used to promote drying. Next, we will focus on the composting method. Surely, you have heard about this method before. But what does it really mean? Composting makes use of the natural process of biodegradation via microorganisms. These microorganisms degrade protein, carbohydrates and fat into carbon dioxide, water, humus and heat. But very importantly, they need oxygen to do so. From 100% organic waste, 30 to 40% compost remains on average. Typically, the composting process consists of two phases. In the so-called intense phase, all easily degradable organic material is degraded. Microbiological activity is very high in this phase, which causes a temperatures increase up to 70 degrees, quite hot. We call this effect self-heating. This phase typically lasts about 1 to 3 weeks and is followed by the maturation phase. It lasts about 8 to 10 weeks and temperatures drop to 20 to 40 degrees. Let us take a closer look at the waste, what is suitable for this composting process. Sources of organic waste can include organic kitchen waste, like vegetable and fruit remain, potato peels, eggshells, coffee and tea grounds, tea bags, organic garden waste, like grass cuttings and leaves, trees and branches, roots, herbs and moss, parts of plants, flowers. Other sources include agricultural waste and waste from the food industry. The basic requirement for selling compost is producing high-quality compost. To this end, you need to have pure material and avoid contamination with toxic and interfering materials like heavy metals. Compost quality is also defined by organic matter content, water content and nutrients like sodium, phosphorus and potassium. Hygienization of the compost must be mentioned here as well. Through a self-heating, all dangerous components, such bacteria, are killed. It's better to have lower quantities of high-quality compost than the opposite. High purity can only be achieved by the separate collection of organic waste. That is why good public relations are important. In addition to the purity of the material, there are some other basic rules for achieving an optimal composting process. A good mixture of different types of organic waste is required. The mixture is reported in the form of the carbon to nitrogen ratio and should be between 20 to 1 and 35 to 1. The correct mixture also helps to guarantee sufficient air exchange. In addition, you need sufficient structural material like branches in order to guarantee a good exchange of air inside the material to be treated. Please monitor the water content. It should be between 45 and 65%. If the water content is below 25%, microbiological activity slows down significantly. Activity ceases below 10%. If the water content is too low, it is necessary to add water. protect the material against uncontrolled wetting or drying. A roof or a membrane covers the material and protects it from rain or sunshine. In addition, it is important to maintain good aeration so that the microorganisms have sufficient oxygen all time. Aeration also helps to dry the material to avoid overheating and to remove carbon dioxide. Quite a few functions. We'd better take a closer look at this point. In principle, we distinguish between two types of aeration for the composting process: passive versus active aeration. Through the self-heating of the microorganisms, the temperature inside the heap increases. The heated air rises and leaves the heap. It causes negative pressure inside the heap, and fresh air is sucked inside the heap as well. This mechanism is called passive or natural aeration. This explains why structural material is needed inside the heap. Such materials guarantee the required homogeneous airflow. It is also possible to actively support aeration by means of pipes under the composting heap. Two options are available for this. The first is to blow air inside the heap. The other is to suck air out. One advantage of sucking out the air is the resulting reduced odor emissions. The composting procedure involves different phases. The components of a composting plant also depend on these phases. Let's take a closer look together. The delivered waste is registered and weighed. Afterwards, it is stored in the reception area until further treatment. The aim of the preparation phase is to provide clean, contaminant-free input material for composting. The second aim is to provide optimal physical conditions for composting, e.g., through mixing with structure-providing components like cut branches. This can be achieved with suitable equipment for shredding, sieving, separation and mixing. After preparation, the material is transported to the composting area. Let's follow the material to this area. Composting takes place in heaps. In case of systems with passive aeration, sufficient turning of the material is required in order to homogenize and mix the material, but also to support aeration and mechanically break parts into smaller pieces. In the intense phase, turning is required at least once per week. In the maturation stage, turning every 2 weeks might be sufficient. In systems with passive aeration, sufficient turning of the material is required in order to support aeration and to homogenize and mix the material. If active aeration is used, turning is not required as often as in natural aeration systems. What a nice smell! Let's get back to the overview of our plant. After the composting process, the material undergoes final treatment to sieve out unwished materials and to obtain different fraction sizes for various uses. Further components of a plant include a storage area, administration buildings for offices, etc., a traffic area, and, if necessary, a biofilter to reduce odor emissions. Now, you might ask how much surface area you will require for a composting plant. The values depend on the capacity in tons. For example, I need a plant capacity of 5,000 tons per year. The surface area needed is between 0.8 and 2 square meters per ton and year. The required size is between 4,000 and 10,000 square meters, depending on the type of composting technology chosen. For example, triangular windrows have a larger surface demand than trapezoid windrows. The average required size is about 7,000 square meters. In principle, we distinguish between 3 composting types: fully closed systems, indoor systems, and open or sheltered systems. Within these 3 types, we distinguish 3 procedures. First, there are static procedures in which the compost material is not moved during the whole process. Second, there are semi-dynamic procedures in which the compost material is moved at some point within the process, e.g. through the turning of windrows. And there are also dynamic procedures where the compost is moved continuously throughout the process. Depending on the substance and the process, the main decomposition requires only 1 day to 1 week. Afterwards, you proceed using static or semi-static procedures. What can you do with all this high-quality compost? Well, you can sell it to different consumers who need it for agriculture, gardens, public green spaces, wine or vegetable production, recultivation measures or forests. To work economically, a few aspects have to be considered. The required amount and quality need to be checked in advance to make sure that the compost can be utilized. Also, possible selling prices for compost need to be checked, and maybe you have to adjust the plant's operation as a result. Another important aspect is the location of your plant. On the one hand, it shouldn't be too far away from potential consumers to avoid high transport costs. But some exclusion criteria apply for the site selection as well. Remember that organic waste has a high risk of leachate emissions. Therefore, plants must not be located in protected areas, water reservoirs or flood zones. Also, plants might produce odor and noise. Avoid locating plants very close to or upwind from residential areas. In conclusion, you can see that dumping waste together with other waste causes big environmental problems. By handling it separately, you can reduce the landfill volume and even generate profits from the waste, in our case, the compost. To improve the environment, you don't have a choice. Go for biological waste treatment. Go for compost. Thank you very much for your attention.